to properties of real numbers. Our objectives today will be to classify real numbers, and then tomorrow we will look at using properties of real numbers to evaluate expressions. So I've split this lesson into 2 videos and 2 days. So here are the sets of numbers. The real numbers you can abbreviate with a capital R. These are the numbers we use in everyday life. All of the numbers you work with are real numbers. Rational numbers, we use a capital Q to denote this group. Rational numbers are anything that can be written as a fraction, including decimals that terminate or end, and decimals that repeat. So if you think about this, the decimal 0.25, we can write as a fraction 1/4, so that's a rational number. The decimal 0.6 repeating, we can write as the fraction 2/3, so that's also a rational number. Decimals that terminate or repeat are rational. The opposite of rational are irrational numbers. We use a capital I to shortcut this one. We cannot write these as fractions, meaning fractions where we've got just numbers and no other symbols. So these decimals do not end or repeat like the number pi. That's an ongoing decimal that never ends. And the square root of 2 is also like that as well. Any square roots that do not simplify into whole numbers fit into this category, the irrational numbers. If you try the square root of 2 or the square root of 3 or the square root of 5, any of those numbers that are not perfect squares on your calculator, you're going to get a long decimal that doesn't end, nor does it repeat itself. After that, we have the natural numbers, capital N. These are the counting numbers. They start at 1 and go up from there. We do not include fractions or decimals in this group. The whole numbers, W, same group, but we also have 0, starting at 0 and all the positives. And the integers, we use a capital Z for this group. These are the numbers on the number line. Basically, it's the whole numbers and their opposites and their negatives. So again, no decimals or fractions in these groups. The integers contain the negatives as well. Here's a chart that will help you decide when you're looking at a number and how to classify it. Everything is a real number, so you start at the top with the real numbers. From there, you have to decide, is it rational or irrational? It's one or the other. So rational means it can be written as a fraction. Irrational means it cannot be written as a fraction. And then from there, you decide, is it a natural number, a whole number, or an integer? And I would just go back to the list that I gave you on the last slide for those. Okay, let's try it out. So letter A, we need to name the sets of numbers to which each number belongs. The square root of 16 in letter A, this is a tricky one. This one here that they gave us is not in simplest form, so you have to watch out for that. The square root of 16, 16 is a perfect square, so we can actually rewrite it as the number 4. And you need to do that. We don't want to think of this as the square root of 16. We want to think of it as 4. Okay, now let's list all of the sets that 4 belongs in. Starting at the top, it's a real number. Use capital R. Now, is it rational or irrational? Well, 4 over 1 is the fraction, so that means it's rational, capital Q. Is it a natural number? Yes. Is it a whole number? Yes. And is it an integer? Yes. So 4 belongs in 5 groups: the real numbers, the rational numbers, the natural numbers, the whole numbers, and the integers. And I've used the capital letters that I can use to abbreviate those groups. Okay, letter B, negative 18. Let's start at the top. It's a real number. Can it be written as a fraction? Yes, negative 18 over 1. So that means it's a rational number, Q. Is it a natural number? No, because it's negative. It's also not a whole number, but it is an integer. Negative 18 is definitely an integer, so we've got 3 groups here: the reals, the rationals, and the integers. And letter C, negative 7/8. Starting at the top of our list, it's a real number. It's a fraction, so it's definitely a rational number. Remember, we use Q for those. And it cannot be a natural number, a whole number, or an integer because it's a fraction, so it doesn't belong in those groups. Let's try a few more. The square root of 20. Can we simplify that? Well, 20 is not a perfect square, so the square root of 20, if you try it on your calculator, will give you a long decimal that does not end and it does not repeat. Remember that these square roots that we can't simplify to whole numbers, they belong in the irrational category. So if I start at the top of my list, It is a real number. Everything is a real number. And then we can't write it as a fraction. You can't think of it as a fraction, okay, because it's got a square root symbol involved here. So the square root of 20 is an irrational number. All right, R and I. Then we're done. Letter E. This is 0.45 repeating. 0.45 repeating. Starting at the top of our list, we've got the real numbers. Now, is it a rational number or irrational number? Well, remember, go back to the definition. Repeating decimals always can be converted into fractions, always. And if you want to quiz me on those tomorrow, you certainly can. But this repeating decimal can be written as the fraction. Let me check it out here. As the fraction 5 over 11. 5/11ths is 0.45 repeating. So repeating decimals are fractions. So they are rational numbers. Use the letter Q for that one. And then cannot be a natural number, a whole number, or an integer because it's a decimal. So this is where we stop. And our last number, we've got letter F, -185. Starting at the top of my chart, it's a real number. I can write it as -185 over 1, so that makes it a rational number. And then if I go down from there, it's not a natural number and it's not a whole number because it's negative. It is an integer though, so my last group here is the integers, which I'll use a capital letter Z for. Okay, and that's how you classify those numbers. So use the definitions and use the chart I gave you to go through those lists. Ask yourself about each and every list with your numbers, and then don't stop until you've finished your list. So that's that. I'd like to check for your understanding here. I'm going to have you try these 5 on your own, following the same directions. Name the sets of numbers to which each number belongs. Try it out for these 5 here. You might be able to find some of them in your textbook. And then bring them to class with you tomorrow, and we'll go over the answers so that you can see if you got them right.